Hello Tech Titans, welcome back to our DK Code Lab YouTube channel. First of all, I would like to thank everyone who supported this journey. Kindly do support and subscribe for our channel, and don't forget to click the bell icon to get the updates immediately. If you really like the video, please give thumbs up, and if you have any query, comment on below. I will answer your queries as soon as possible. And if you really like and worthy, kindly share it with your friends. Without any further delay, let's get started. Before starting our video, I need to introduce the GitHub code repository. This is where I put all the code whichever we are doing in our tutorial. You can find this in the GitHub link. I will give this GitHub link in the video description. Kindly check it out and practice in your local machine. In our previous video, we have explored how to set up and how to run our first Spring AI application using Ollama. In that, we have used ChatClient as the high-level interface to communicate with LLM. In this today's video, we are deep dive into ChatClient and ChatModel. Okay, from that you can understand what is the ChatClient. Is this ChatClient is really talking directly to OpenAI LLM AI providers API? Where does ChatModel fit, and what are the prompt and messages, and how the response are converted into and mapped to chat response, and how does the Spring AI hide all the complexity inside our LLM calling. Okay. The flow, how the flow should be. Okay, this is the Spring Boot application. This application you are calling the LLM using ChatClient is the high level abstraction Fluent style API. Okay, through this you are constructing the object required for this, and it internally calls the chat model. This chat model is the low level interface that gives some low level abstraction and contracts that every AI provider should follow. In that, we have different type of AI provider that has a individual implementation called OpenAI ChatModel, Ollama ChatModel. Each internally uses the OpenAI API or Ollama API as per the LLM provider's API. This is the transport layer that makes the HTTP REST call to OpenAI LLM server to get the response back for the prompt we have given to the LLM. This is again processed by Ollama API, construct the response object and give it back to the Ollama chat model. This gets some implementation respective of Ollama. Again, this is a chat model. It's the contract only. So we are constructing the response back to ChatClient, and we are receiving the proper response from the LLM. In this full flow or implementation, we have multiple interfaces implementation. To hide this all the complexity, Spring AI gives one interface called ChatClient. This is the developer friendly high level abstraction Fluent API style interface. So we can work around with different AI capabilities with prompt construction, and advisor. In the further videos, we will use the advisor to process the request and response before the model calls or after the model returns the response. It's like a pre-process and post-process. How we can provide the context of previous conversation using the chat memory and RAG implementation and MCP in the further videos. So you will get to know the power of ChatClient there. First, in this video, we are going to see about only how we can minimally use this ChatClient, how it avoid its most of the complexity inside the Spring internals and provider specific APIs, how it fits with chat model to communicate with underlying LLM providers. Okay, this is the overall architecture. Our IDE to get the hands-on experience and explore everything via our code itself, so that you can get the overall topic idea and also get the hands-on experience how to use that your how to use the specific implementation in your code and what error we are getting. Let's get into this our video. Actually, in this IDE I copied in the previous video whatever we developed, and I copied and put it in the one folder and rename it, and the same you can see we have only the Ollama model is already added. As the previous video we did these changes and run our first application, same implementation only. Somehow I changed the name of the file folder and this package common package name, and I changed in the pom.xml artifact ID. And also after this video I will push all the changes we have done in this video to our GitHub repository, so that after this video you can clone this repository using Git, and then you can work around in your local machine. Let's jump into our things. First of all, in the previous video we have just implemented the one interface. That interface contains the one method chat. Using the chat method we are using the ChatClient to communicate with our low level LLM API calls, but it's the abstraction level. We can dive deep into that chat model and chat client in this video, so that you will get the full picture of why we are going to chat model and chat client. You will get some understanding. Okay, for that I am creating one package called config, so that we can organize our configuration related to Spring AI in this repository, sorry, in this folder config. I create one class name as Ollama config. I created the class to make this class contains configuration. I'm using this annotation called configuration. In this I am going to configure the bean called Ollama API. This is the Ollama API. This is a provider specific class. Here you can see this is a provider specific class that uses the Ollama as the provider. In this we have the useful methods called, we are using the base URL and important steps to directly communicate with our LLM providers. In this we are constructing this object using the builder method. Here we can use Ollama builder. In this we are building the object using the base model. This contains the what is the default URL for this 11343. This Ollama is the low level API provided by the specific Ollama LLM provider, so that we can configure our URL custom. But basically the Ollama is running on this port called this 11434. So copying this port and pasting here, I think 434. If you get into this Ollama API, this contains a builder method. In this builder method already that has the default URL of localhost 11434 and the steps we needed for the communicating with here, because all the HTTP calls are made using our REST client or REST template. Here the REST template is deprecated. That's the newest version is REST client. This is used for making the synchronous HTTP call. The web client is used for streaming response or our asynchronous non-blocking, making the non-blocking calls. And if you want to in the future we want to handle the error with your own implementation, you can utilize this method. But as of now we are using the base implementation using the base URL, so that our LLM or API can connect to local Ollama server that running on the port 11434. Why I am here creating this is so you can get some idea of why we are migrating from this low level provider specific API to ChatModel and chat in few minutes. You will get some idea. After that, this is the Olama API we created. Next, if you want to use this Olama API and you want to construct this request response means, we can go in the chat method. Currently I'm removing this one. I'm not using the Spring client and all, so that I'm removing. So here I am auto-wired or whatever we created in the Olama API. I am auto-wired here. We can make it as perfect because we are going to use constructor-based injection. Here, Olama API. Next, this dot API is equal to, we are assigning this whatever Olama API being we created in the configuration, it will get injected in this service implementation using constructor injection. This is the basic Spring Boot functionality. Next, we need to construct the object for making the request types. Here we can API chat request. Here we have one chat request. If you go here, you can get the idea. This Olama API. Here we can have one record of type chat request. In this only we can give our what model we are going to use. The message here is the user message, whatever we are getting from the user, and whether the stream is here for whether we are expecting the blocking request or a synchronous client or a streaming response. Without getting the response, it's asynchronously give the response. We can use in the in the ChatGPT, we can get the response instead of waiting more time. It will streaming the response, right? Like that we will get the format. This is the advanced tools. Here for our demo purpose, here we have one chat method. In the chat method, I created the message with the user role as the whatever the user wants to ask the question to LLM. I am passing it into the user messages, and in the system messages how we can control the AI and how this should be behave for the particular context. Using for that I created one prompt. In this I will inject it into the chat request. For the making the request, we need to prepare for the chat request. In the chat request equal to Olama API dot, we have one method called chat request builder. The builder we have to pass the model. It should be not null, so we are passing the Llama 3.2 as the model. Build. This is used to create the object. In between, we are passing the actual response. In the message section, I am passing the two roles of user message and system message. I think this is one second. After this creation, I am mapping to the local variable. Olama is a chat request. This to a chat request. If you look into this Olama API, we have one method called chat. This is used to communicate with the LLM using REST API call. So we are using the same method. We already created the bean for this one. So we are directly using this Olama API dot chat. We are passing the chat request. This gives the output in the format of Olama API dot chat. This is mapping to one local variable called AI chat response. This response is the format type of chat response. The chat response contains the property of model created at message done reason. Here for the response we are getting from the LLM, that is coming inside the AI chat response dot message dot content. This should be in the type of the string. The string we are directly returning the content. Okay, here I created the Olama API using our custom bean inside our config. This is not necessary because we are using the power of Spring Boot auto configuration, so that the Spring itself automatically creates the bean of type Olama API at the application startup. so no need to create. If you want to customize your low level API functionality, we can use this bean, so that the Spring will use user provided bean instead of auto configured by the Spring Boot, because we already override the bean definition with our own implementation. Spring Boot skip this part, so that it will use our own implementation, so that you can have the low level control of our low level provider specific API. But it's not necessary here. I created so that you will get some clear idea about how internally it's working, and how to configure it manually by using our bean annotation. Okay, it's the time to run our application. Go to our Spring Boot application, start our main application using this. A Spring Boot application is up and running and listening on the port of 8080. Go to the Postman. I open the Postman, and in this previous video, local machines takes some time to here, even though this who has win the FIFA World Cup, but in the system messages I configured with the behavior of you are the Java expert, answer all the question with example, so that it's try to modify our input to according to the system whatever we are given. I became this write Java program for paper Maki series. If I try to run this query, since this model is running on our local machine, it will take some time. Here our LLM provide the response using our LLM low level API provider API, low level API. In that it can generate the program efficiently, so that we are connected. Thus we are getting the proper response from LLM. Here we have many disadvantages, because this Ollama API is particularly bound to Ollama AI model. Suppose in future you want to integrate with OpenAI provider API, means it's very difficult to adapt to OpenAI, because already written the code with Ollama API. In the future you want to change, means you have to do lot of changes. It is violating the solid principle, because always the solid principle suggested that your class should be open for extension and closed for modification. Here you are changing your implementation for the different API like OpenAI API or Azure API. You have to change manually. So in this example, it is tightly coupled with your AI provider specific APIs. So it should not be the case in our modern development, because we cannot maintain our code very easily. It is very, very difficult to scale at large. So okay, so avoid the situation only, we are moving to ChatModel interface. Here the ChatModel interface is the Spring AI abstraction that abstracts and creates the contract, so that all the AI providers should other to the ChatModel contracts, they need to provide their own implementation, so that we can use the any AI providers and we can change the AI purpose without doing much manual work in your code. Because why I am saying here is, for example, here I am using OpenAPI. If I use Ollama, here I am using Ollama API. We want to use the Open API, means again I am creating some pseudocodes like Open API dot message completion request is equal to Open API chat request. Here you can see the comparing to Ollama API, the chat request object itself changing, and also response format also changing, so that we have to manually change the code according to the different providers. So it violates our main principle we are used to in the software engineering called solid. So avoid the situation, Spring AI introduced the interface called ChatModel, and it also is tightly coupled to your AI provider. Response is difficult to manage the response object at scale, response object and a request object, and also we have the manual object creation for user messages, system messages. All the things are happen, and also Here, what is the disadvantage means every AI providers we tightly coupled with different AI providers. Each AI providers has different request format, response format, and different handling of the object. Here you can see the Olama API, we have the completion, chat request. In the Open API, it's the completion. It is totally different. So we have to do more manual code changes. Okay. Here how we can directly move to chat model, so that how we can reduce our dependency with different AI providers. I can remove this line. I create one more endpoint with here also returning the string chat with chat model. Here also I am passing the same message. Here I am implementing the method called chat with chat model. Here what I am going to do here is, again I am going to configure the Olama config. That this is for if you create the bean, it is applicable for the whole project. Okay, if you want to, we can create your own bean and customize your bean. We can create your bean definition. Okay, public chat model. Here I am going to create the object of bean type of chat model. Here the chat model is the interface, low level interface. Use this low level interface we can call our LLM with very easy manner, because it internally uses the prompt. Whatever we are passing in the message, it automatically map it to the prompt, and it internally uses LLM or a LLM provider or a provider specific API like Olama API to connect with the LLM servers. Again, it's mapping our response back to generation object, so then from that we can get our output with some extra stuffs like metadata and with its contents. So we can the chat model. Here I am going to create the chat model of type Olama chat model. Here the chat model is interface. Other what we can give the implementation. Here one implementation is Olama chat model, because we added the Olama AI model starter model as a dependency. It automatically discovers that the only one class that implements the chat model. Here you can see the chat model. In the chat model internally uses the Olama API to make the request to the LLM provider specific API, and some we can pass additional some Olama chat options, default option while integrating with API, integrating with LLM. Okay, we'll see one by one in this video. Creating the here we create chat model, return Olama chat model. We are going to use the builder pattern, build the same. The chat model internally use the Olama API only, so that we can pass our whatever we have previously created the bean called Olama API. The same we are passing here, Olama API. We are calling this API. Otherwise we can Olama. We are calling the same method. Next, we have some default option. Okay, here we have some default option. We'll come to later, but we try to run this service using this one. Okay, the same. Instead of directly using the low level provider specific API, we are going to use chat model. We are injecting this in the chat model. This bean is created inside our config. Here in chat model, this chat model equal to chat model. This is a chat model, is the low level abstraction provided by the Spring AI to communicate with AI, that has the common functionality of calling the LLM and mapping the response from the LLM to chat response. This is the primary purpose of using this chat model. Okay, so that I already mentioned chat model contains one method called call. In this method we can give the message. From that you can get the AI chat model response. Here you can compare this the code you have written for this low level provider specific API, and then for using the chat model interface provided by the Spring AI, that is the abstraction layer around the different provider, so that we can directly call our model, the AI model, using the common method called call. This call method is present inside our chat model. Every AI provider implement this chat model interface, give their own method of calling. Here we are calling this message, we are calling this call method only. This whatever this happen now, this call means, if you see this method, we are using this call method with passing the user query. In this user query is in turn appended into our prompt. This is a prompt object. This is the object used to communicate with LLM. So the instructions are passed via the prompt only. Okay. This prompt is given to this call method. Here this call is the overloaded method. This is the default method, and this is our abstract method, because the implementation is provided by specific AI providers. We are calling that call method using this prompt, so that a AI provider make use of the OLAM. So for example, OLAM API as the transport layer to communicate with the LLM provider and giving the response in the format of chat response. Here the chat response contains the different useful data. Here the chat response contains the response metadata. This contains how many tokens are used and what model it has been full stubs, other like what is the finished reason for that, and other important subs are wrapped inside the chat response. Okay, so for getting the result, we are using the get result method. Using this get result method, it gives the generation. Here the generation means the each unique the response generated by the AI, that is called as generation. The AI based on the AI provider, the AI can give the multiple generations. For example, in the ChatGPT, you can like that, go to the give to response. For example, I'm saying this is the response one. This is considered as one generation. This is considered as second responses. If the AI provides suppose this type of generation, we can utilize most of the cases we are getting the first response generated by the user. So it's mapped to generation. From the generation, we are getting the output. In this output contains some useful important steps like what is the assistant message, chat generation, metadata, and all expression. So here we need only text, whatever the content generated by the AI. So we are mapping using this get text. It returns the response in the form of string. So here for that, so while calling the call, it gives the response in the format of string. Okay, if you want, you can get this as chat response. We can get the chat response also. Once again, call. If you're calling with string message, it will return the message in the string response. And if you want to get the response in the I'm running this, first of all I'm running this service so that you can get the clear picture of what is the difference in those methods. Started. What is the end? I need to create one endpoint, right? Otherwise it's difficult to. I'm duplicating this. And also chat model chat send message using chat model. Same only here I'm changing to chat with chat model. That's all. I'm copying this endpoint for calling in the postman. I'm rerun it again. The same port only our server is running. So here the endpoint only is different. I'm calling with same the query before we asked. Okay, try to run this service. Why we got this error? The model mistake is not found. Okay, you see in the configuration. Oh no, we are not passing any of the model information, right? We have to pass the default option Olama ChatOptions.builder. Here we have to provide the model as Llama 3.0. Because of this only it's getting error. Previously we are using this property based configuration, but now what we have done here is we have created our own bean using the Olama API and the Olama chat model. Spring assumes that you are having the bean definition for that Olama API, so it's not injecting the auto configure bean. If the Spring injects the auto configure bean, it will come up with this configuration. But we have defined our own bean implementation, so that only it's giving this error. So that now, because of this error, you got some understanding about the Spring Boot auto configuration with our own implementation of bean. Okay, Spring only inject this bean if you not configure, but you already configured. So that is assume you have the provider, you have the bean provider, bean definition and implementation. You should provide all the necessary steps, like that the Spring is telling to you. Now again rerunning whether this she got result or not. Let's see. Go to our Postman and hit it again. Yeah, here it is. We are getting the response from the LLM. So here our business logic is same only, whatever the Olama API or chat model, but how we are returning our code with more maintainable scale at the large, that's the matter here. And also we are following the software engineering best practices and principles that are used to maintain our code. The business logic is doing the same thing only, but how you are managing the code while growing our code with in future, how you are managing the code, how your code is handled in the large situation. Here using the interface, our code is very adaptable, so that we can implement with different provider, can also work with the same code. In the future, if you are changing with a different provider, means here you can directly go to the configuration. You can remove it here. Instead of Olama, you can change it to Olama and Olama to OpenAPI, so that it will work as previous. That is the power of using this chat model. You understand, right? What is the usage of this chat model? So that here you can create our provided independent APIs using the chat model. I mentioned, right, you are getting the response in the string if you call the method with some prompt. Here I am giving the prompt. I am creating the prompt object, new prompt. Here the prompt is the object used to instruct the AI with different roles. What I am saying here is the prompt has the different roles. Each role has one purpose. For example, if the user passes the message, user wants to know the answer for the particular query, that is called user. That message contains the user role, the role of user. If you want to, whatever the user types, but the AI should behave for the particular instance, it should behave like this. That control is given using the system. And third one is here I am explained with this message role has 4: user, assistant, and system and tool. Each has one different functionality. User means user role has bound to what the actual query by the asked by the user. This system controls the AI behavior and context. Assistant role is mainly used for giving the AI to the context about our conversation. For example, assistant role is comment effectively in the, for example, takes the ChatGPT as the example. The ChatGPT, I am typing this question, give the 2 response in the same prompt, but this gives the element of some error. But I am asking the same question, follow-up question with the side by side, so that the AI can understand. I am mentioning about the previous response, whatever generated by the AI. This previous response, the AI should not know. We have to give it as the assistant message or as the chat memory. We will learn about this in the further videos, so we will get the good understanding. But I am explaining here to give you the basic introduction or basic idea. Okay, next. In this place only the command object. Next, tool means here giving the tools response, tools about tools later info. For example, in this scenario, in this example, in the get weather API, you want to the AI wants to invoke the get weather API. So in this place, we are using the tool as the message to give the tool related information back. Tool related, after executing this tool, we are getting the response. That response is appended inside the tool so that AI can generate the response based on the output generated by the get method. Because AI have the idea to whatever tools available in our system that are exposed using tool calling while using the tools, so that AI can request our application to execute the tools with some actual request and expected response parameter. After that, AI application will invoke this endpoint and give the response back to using this tool. This is the place where we are using the tool. You get some idea about this message rules here. Next time we are going to learn about the prompts. Here we can give the different types of rule: new system, new user message, content of message, and new system message. System message, I am using the same system message whatever we are configured in the for the Olama, the low Olama API. It should be in the string format. After creating our prompt object, we need to pass it in the call method prompt. Here this call method returns the response in the format of chat response, so we are mapping to chat response. Here we are expecting in the string format, so that how we can get this chat response result means, first we have chat response or get results. We have the different methods which in turn return the different information about that. Results means it contains the list of generation. So I am happy to here one the local variable list of generation. Okay, I have already explained the one method, one AI LLM call contains many generation based on the AI provided capability. If you want to all the generation, you can get it from there. Otherwise, you can use chat response dot get result. It map to generation result. This generation contains the generate result dot get output. This get output. This contains the assistant. I already said this contains the assistant message. Assistant message means and the response given by the generated by the AI is in the form of assistant response. This assistant response we can get the actual content using the text. Here we can map it to. This is the final AI generated response in the format of string. We can directly return the text. This is the process of using the prompt with the different roles, and the different role each has one responsibility and defines the purpose of these messages. Here the user messages purpose of handling of the query asked by the user. The system message has the role of defining and control the AI behavior, and then using this prompt object we are calling the chat model. Internally it uses the low level provider specific API and return the response. After that, like chat model convert it back into chat response object. This chat response, we have the different option and information. We can get it from there, so that we can get the generation. Generation may have single output can contain multiple generations. From the generation, we are getting the output in the assistant message. Assistant message has some important information, whether the tool call. If you in the further lecture, further videos, we will see the tool call, different tool calls for the particular LLM call. What we can append the media, whether any media type is written by the LLM based on our input means we can get that one also. For that purpose, we are using the assistant message wrapper around our text. From that, if you want to get the proper text content, use the get text. This is the purpose we are using the chat model, and also this has also some limitations because we can manually create the prompt object with the different roles, and also it does not it gives some functional style of step-by-step program, step-by-step instruction or step-by sequence of lines to execute and get the results. Instead, if you want to use the Fluent side high level abstraction and also add more functionality like as adding the advisors. Here the advisor means before calling the AI or after calling the AI, we need to pre-process and post-process the request so that we can efficiently call our LLM and reduce the API cost. For the purpose, we are using the advisor and also using for logging purpose, and restrict our AI to not use the some words that is very abusive means. Yeah, we should not use that words. For that, we are using the advisors and chat memory. We want to give the context about previous conversation. We need to include. We can include our chat memory capabilities. And the RAG implementation, MCP tool calling and functional calling, these and all. If you want to integrate means it is very difficult to use it in the chat model, because the chat model has the principle of single responsibility principle. This class has one responsibility, calling the API using the prompt and giving back to the response using the chat response. This is the actual behavior of chat model, the underlying core abstraction used in this. Okay, to further we need to reduce our code and developer, and also it should be developer friendly high level abstraction with the Fluent API style. We are going with ChatClient. Okay, and also this, before jumping into the chat line, I have some some additional options need to be we can configure in the prompt, because in the config this is the default option we can provide. We have many options like frequency or temperature. Temperature here is 1.7. The temperature controls how your model should be, whether our model should think whether it should be in predictive or very creative. That is handled by temperature. Now more temperature gives the more creative response back to ours using LLM. And then we have different options like frequency penalty. We give the frequency penalty as 0.5. This for controls the model response. Control the model response. Control the model response, whether it's a predictive. Predictive means give the proper response. Proper response with info. Low, higher than higher means creative. Give hallucinate. Hallucinate is possible. Hallucinate. The frequency penalty is mainly used to for reduce the repetition of. The more you give the penalty, it's up to 1. It reduces the repetition of same words in our for example, Java is platform independent, Java is secure, Java is object oriented, like that. It uses this. It use the same phrases or words again and again. To reduce that, we can use the frequency penalty. After that, we have presence penalty. Presence penalty as 0. If we give more the number of presence variety, you just use the diverse the topic instead of staying on the same topic, and give more vocabulary, and uses the give more vocabulary. Okay. This is because this mod is created only once, injected all the places wherever we are using the chat model. If we want to control the behavior in the every request means we can give the chat options here also. So here we can create the chat options. Chat options builder. Here also for every request which model you should use, the same model only, Llama 3.2. That same temperature. Here the temperature should be 2.2, so that it will get override for the every request. It is the common for all the requests made using chat model, but here this is different for every request. This is override by the every request. Suppose there you are given the temperature as 0.5. Here for every request you should use this to mean this will take the precedence, because this only gets appended in the prompt and injected into our chat model call method. Temperature, again frequency penalty 0.5, 0.6. Based on the provider specific, this value gets adjusted because the presence quality may be for the opening minus 0.2 or 2.02 plus 2.0. We need to go through this documentation because every chat provider has a different implementation. Based on the provider, you can configure the value accordingly, so that we can use the maximum ability of LLM to generate the options, and also we can use the max token to control, so that it will control how many tokens it can use to generate the response. So that using this max token we can reduce our API cost, because it will stop the LLM generation in between up to 200 times. After that it won't generate the response for the particular request, so that we can reduce our cost and also making the response size as expected. We can configure it for every request, or globally also using the default option we can configure. Okay, and these are some of the important chat options here, and passing these chat options here. Options you should not pass here. You can make this as Control X, and I'm making list of message from the AI chat messages. Okay, it's the common chat coming from the common model. Otherwise, it will take the message from the Ola maybe. We don't want that one. So messages equal to list of. I'm passing this response here. the same only, but I'm wrapping with our list. And then here we are passing the options and then messages. You can see message and chat option. First you have to pass the message and then messages and then option. This is the correct way. And then we are calling this again. Suppose your max token is 50, means we can get the response with 50 tokens only. We can see I am renaming the app again. My server is running. I am going back to the thing. I'm running the same service. Here you can see, right, this is the assistant message. The example try to generate, but we have given the max token of 50, so that stopped the generation at the 50 tokens. This is the advantage of using this, so that in our organization we can reduce our API cost and limit the response with some concise size with allowed with the defined our organization level. So okay, this is the purpose of using this default option and overriding the option with prompt. Next we are jumping to into our main high level Fluent API style API called ChatModel. This is the interface we are mostly used in our implementation. Okay, here also you can create your own bean. Here the public ChatClient. Return the ChatClient. We create the ChatClient using builder. The builder you have to pass the ChatModel. Okay, ChatModel. Here also we can pass the same default option, Olama chat option. Otherwise, what I am going to do, I am creating this. I am removing this from here and copying this from here. This is the private variable I am creating, so that here using the same Olama options. And also here also I am using the same Olama option as the default option. The same option, because why I am here put it here means we can use the same Olama chat option here and here also. The same only. We are building the chat client with here you can see ChatModel and then default options. If you want to set the default system message, means you are a Java architect, answer the question, example. Okay, I am passing the same, and also I am passing the default system name, and also we have the different option, default advisor. In the further class we will see default system. We have the different constructors. We can pass the source from the file. We can load our prompt. We will see this in the next videos, how to configure it. And also we have the different tool calls. This is used in the MCP client and MCP server implementation. We will see, and all the Ravel elements also we see. And default user also we can test. Default user, this will get injected in all the places. We want to override the system name with here means we can use the prompt here. I'm going to create one going to create one chat with chat client, same set line. I'm implementing the same. Private final chat client. I already created the bean inside the config. I'm directly injecting here chat client. It's a chat client, and it's the same. Return chat client prompt. This is the user message. In the user, instead of creating the prompt object with like this syntax, we are creating using the Fluent API. Fluent means the chain type API style with so that we can call with developer friendly. Here the user, we are calling the message. We want to override with the system means system. We can give the system, but already we configured in the default system in the our bean definition itself in implementation. And then we have to call. This call is actually called the ChatModel call option, and finally called internally called Olama API. It is a transport layer connecting to the LM. I bring the response and wrap it around with ChatModel again wrapped with chat client, so that we can get the response directly using the content. Instead of chat response, we can directly get the response using the content. It instance return the response only. Okay, here I already returned, so that no need of return again. For this we can create one controller, chat client, sending as with chat client, chat with chat client. Chat with chat client. Okay, chat with. I'm copying this endpoint and try to run it again. Yeah, our application is up and running without any error and also is running on the port of 8080. Going back to our postman and hitting the endpoint that configured for the chat client and hit it again. Yeah, we are getting the response from the LLM using our chat client. The same implementation, business logic, but different syntax and code section. The same concept only, but here the code you can see how many lines of code it has reduced using our Fluent API, so that it will get the difference. But for one API, if you develop more API with the same prompt, means it will get more line of code and reduce the, and also easily maintain with our Fluent API. And also if you want the same chat response, you can get the client chat response and mapping to, instead of returning, we are mapping to chat response, again chat response, so that we can get the some metadata information, other important stuffs that are previously seen in the chat response type. Again the same code section we can use to get. Okay, yeah, this is all about this video. In this video we have covered these points. Okay. What is the chat client? What is the chat? Is the chat client? No, we can use the Open AI or Olama API, low level AI provided specific API to connect with Olama API, Open API server. Where exactly the chat model is getting filtered. This also we got the answer from this video, and I explained prompt messages and chat responses, and how the Spring AI hide all this complexity and give the one developer friendly Fluent API style high abstraction interface called chat client. From that you can use the leverage of whole Spring AI ecosystem with the handy implementation. I hope this video is useful for you, and if you really like the video, kindly give the thumbs up. Also don't forget to subscribe our channel and click the bell icon to get the immediate updates from our channel. In future, if you want me to talk with any of the particular topic, kindly comment on this channel, and if you have any query also you can comment. I will answer those questions as soon as possible. And if you feel really worthy to share with your friends, kindly share, so that for them also it's very useful to know about this technology. Okay, thanks for this opportunity and explain this video. I will wind up this. We'll see in the next video about another AI concept, another Spring AI concept. Okay, thank you, bye bye.